Marshall.
Can you tell us anything about it?
Well, it was the setting for Macbeth. Shakespeare's Macbeth, that is.
Well,
you probably wouldn't hear that.
Military rendition, I don't think it will have picked it up, but it was pretty special.
Did you get that?
Yeah, well, part of. It zooms in a lot, so we don't get to see all of you. So
Hello.
So just off the top of your head.
Hello world. Off the top of my head. Queen Mother spent most of her childhood here, and Princess Margaret was born here, believe it or not.
Here we are working on the D8. This is the material. This is straw off a round bale, like you see over there. It's the bales are put into the bale unraveler, which is this machine here. It holds and turns the bale and drops the material on top of this conveyor. That conveyor delivers the undecorticated stems to the decorticator core. Now that's it there. We'll do a shot in a few minutes from the other side. The material then lands on these straw walkers. Now the straw walkers were removed from a second-hand combine harvester. You can see hurd is dropping out underneath. In particular, that lot there was from the first material that came out of the decorticator. Because it didn't have anything to land on, as right now the straw walkers are not powered. They're just being hand spun. And you can see it's lifting and moving the hemp fibre up and out the back of the machine. Now, here is the decorticator core, the main beater, the infeed. Now the infeed is powered by this weird superstructure at the moment. That is not what we requested. We wanted a gearbox off the end of these shafts, or a worm drive, a direct drive. So we've got, I think it's a 60 horse 3-phase electric motor on at that point. We have, including this reduction type setup, to ensure that we're running the infeed at around 60 up to 100 RPM. That little motor there, I believe, is a 7.5 kilowatt. So that's what we've got powering the system at the moment. Of course, we also have another motor on the bale unraveler. We have the motor on the infeed conveyor, and we'll also need to install a motor at this point to power the straw walker. Now we have a few second-hand motors to choose from. The power requirement should be pretty minimal, but here's the straw walker set up from another angle. These straw walkers are on an odd-shaped shaft, and they spin at up to 200 RPM in a combine harvester. The hurd drops through these grates and slides down a chute. Here's a better example of one. Slides down that internal chute to this bottom area, and it's dropped out there, and that's where we're actually capturing it and using a vacuum system here to deliver it off to the bagging bins over there. So, in a nutshell, that is the decortication line. Dry material, very dusty, quite a good result, good separation. We We just need to get some power on that straw walker. Here we have a quick look at the control box that we've got set up. All electrically powered. We have control over everything from the dust extractors, hurd extraction, the main beater, the infeed, the debaler, various conveyors that we had for the fibre. There is also control over the speed of each of the beaters, so that the beater and the infeed. If one electrical fault comes up, it gives us a light here letting us know which electrical fault it was, but it actually shuts down every motor. So one fault and everything cuts out. Recording some trials of running material in. We'll be hand feeding today, and also we don't have any power on the straw walker. Now the straw walker is the thing underneath the decorticator on the right. The material that comes out of the decorticator will simply all land in the one place, just underneath the decorticator. Start with the decorticator and then do the dust extractor. Start with the decorticator, dust extractor, and then turn on the infeed stuff. the sound to go away, and then I'll take the camera over.
I turned up the input speed just a fraction. Increased the torque. That's pretty good.
Well, I don't know that it hit the stems enough.
Yeah.
I think not being able to turn the beater bar up any faster is a bit of a problem. But let's go in and have a look. We see all the material landed in the one place. That was because the fibres landed, the hurds landed on top. But when you give it a shake, it actually all the hurd drops out, or most of it anyway. Now you can see through the violent action of the straw walker, with those shafts turning at even just 100 RPM, it would do a lot of the shaking, and it would allow the material to be moving along constantly, so the hurd and everything will not land all in the one place like this. It's an agitation. You can see it's walking up bit by bit, and if that were running at 100 RPM, or as fast as it runs in the combine, you see the material just coming off the back there. And you can see the condition that it's in. It does still have some hurd, but I think that's partly because we ran the infeed a little too quickly on this example. But there you see it all drops out. This machine here is the next stage after decortication. This machine is only a small research jig. It's an opener or a rag puller, depending on what you want to use it for. This one was used to reclaim wool out of jumpers, woolen second-hand jumpers. You can see the infeed then encounters a main drum. The main drum has very large, or when I say large, about 3 centimetre tall spiky hooks that rip into the fibres and open them up. A lot of trash is removed at this point. Any hurd that's mated in is removed. The fibre then comes up this rubberised conveyor and goes through a similar process again, another big drum. This drum though has finer teeth on it, more like a series of sort of toothbrush paddles, but still thicker and upscaled, made of metal. They rip into the fibre then comes out the back in this box. In this case it's blown off up this tube, up the tube all the way into this bin, and when it comes out of the bin, this is the condition, this is what it looks like. Still tiny fragments of hurd that you can see there, but this material is very well presented. The next stage after opening is a card. This card is an old card. The material goes through on this conveyor system, is lifted up and dropped down in job lots out of this bin onto another conveyor. It then feeds into the card. Now the card, like the opener, has a large drum. Now that's the large drum on this one. The drum has finer combs on it. That's great. And the material comes off at this end in a web. Now a web is a continuous sheet of fibres that then run up this layering system and come out at this point ready to be needle punched or put into a sliver or whatever. And this is how clean the material is at this point. The fibres are basically all at the same length. There's a very low degree of trash in there. If this card were better adjusted, there would be no trash in there at this point. But again, this is purely a research and demonstration facility. Here's the straw walker that sits underneath the decorticator. The decorticator is up there. It drops the material down here. Now, unfortunately, right now we do not have power on the straw walker. I'm going to run it a little bit by hand, and you can see how it walks the fibre up. The straw walker will normally run in a combine at 200 RPM. Now, we were thinking that we'd run it a lot slower than that, probably at half, at about 100. But I'll just rotate this by hand a few times and you'll see what it does. There you see it shifts the fibre up and allows the hurd material to drop through the bottom here and collect underneath. Now we have a vacuum chute here to capture that material and take it off to our bagging line. Here we are looking at the straw walker. We're just going to run a quick trial here to illustrate how the hurd drops through and the fibre is moved along and up. Now, unfortunately, there is no power on the straw walker at the moment, so I'll be running it by hand. But the decorticator is powered, so you'll hear a bit of noise, and you'll see some fibre dropping down in just a moment. Right up top. Right up top. Get it? Right. see the straw walkers from a different angle, you can see all the hurd has been dropping through, or the majority of it anyway, and off the end the fibre's been dropping. So we're now going to run some of that fibre through this opener, and we'll do a bit of filming while that's going through. It's a very slow machine, this one, very low capacity, but it'll still give us an indication on what the hemp will look like once it's run through. This material here is part of a 100 kilo lot of hemp, a sample that was processed in 2004 in Yorkshire. It was then sent to a dye works, Dewsbury Dye House, where they did a degumming. Now, the material still has a bit of hurd in it. It still has a great deal of colour. You can see the fibre bundles have not been broken apart very well at all. The reason it is in this condition is that Dewsbury do not have a press. So when they put their material in the dye vat, in the pressure vessel, it did not degum as well as it should have. Now, here's some of that material taken from that bag. We've been running it through this rag puller here, the opener, and we're going to run some through now, and we're going to follow it all the way through the process and show you what we get at the end. Here we see some of the dry, round-baled hemp. We've already decorticated it, and you see there's a bit of hurd still in there. That's what the material started like. Went through the decorticator. Now looks like this. We're going to run it through the rag puller, and we'll follow the path of the fibre so that you can see how it changes through this stage of the process.